Yo everyone, what's up? Welcome to a video about equations and graphs. We've been talking about these along with points, and what we want to explore today is how are they related? Brief recap of what we've talked about in the previous videos. We introduced the idea that we have these things called points, and we can have a collection of them that is called a relation, and then we can represent that relation in a couple different ways. So we talked about the idea of having a verbal representation, which is explaining the relation in words, like we did here. We've talked about having a visual representation, which is also a graph. And we've talked about having an algebraic representation, which is an equation. And so the idea is that this graph, this verbal representation, and this equation all represent the same relation. And they all include the same points. And so because it's the same relation and because of the same points, in effect, they are the same thing. They represent the same relation, and so they are the same. And it's not just that they're similar, it's not that they're related, it's not that you can find one from the other. They actually really are the same thing. And to show you, I have this quick Desmos activity. I've graphed this equation y equals x cubed minus 3x squared plus 1. Over here, it's this blue kind of like swoopy curve. And if I take any single point on this, I'll take the point 1 comma negative 1. If I plug in 1 for the x value, we get negative 1 as our y value. Because the equation is all the points that satisfy this relation, and the graph is all the points that satisfy this relation. And it doesn't even have to be whole numbers. So I could pick 1.3, let's get a good one, 1.33, and it should be negative 1.954. So I put in 1.33, and we get negative 1.954. Every point in the graph is in the equation, and everything in the equation is a point in the graph because these are the same thing. And this is wonderful because we want to do things with relations. That's what mathematics is, right? It's working with these representations, and it's also answering questions about these relations. And the idea that we want to look at briefly is that we can choose which relationship or which representation to use based on the questions we want to answer. So here are a couple possible questions we might want to ask about a relation. This first one, what is the coefficient of the x squared term? Well, that's pretty easy to answer with an equation. It's just the negative 3. It's the coefficient right there. This one says, what is y equal when x is the square root of 2? Well, we take the square root of 2, we plug it in for x here, and we end up getting what y is equal to. Really nice to have an equation for this because it's easy to work with. But there are other types of questions where having a graph might actually be a better representation. Here's a couple of them. What negative value of x gives the maximum y value? Well, there's a lot of possible negative x values. There's infinitely many, but with the graph, you can kind of see the answer. Oh, it's like this value of x that's right here gives us that value of y that's up there. I mean, it's incredibly straightforward if you know the value of this point compared to trying to use an equation. How would you do that? We could also have things about finding minimum y values, right? We could have questions about when the relationship is decreasing. Really hard to answer with an equation, kind of straightforward to answer with a graph we're going to see. And we can also have questions about for what x values does y equal 0? And again, by having a graph, those become relatively straightforward questions to answer, much more so than with an equation. So we get to choose which relationship we want based on the questions we're trying to answer. The other thing about these two things actually being the same is that there's kind of a misconception we want to change. Students very often, and even mathematicians, math teachers, think that the idea is that we start with equations and then we can make a graph from an equation. But that's not really the whole story, right? This is actually a double-sided arrow because you can start with a graph and make an equation from that graph, actually. Okay? And what we find is that as we learn more math, both of these representations become more useful. And so being able to move in between them is really, really a good skill to have. Let's look at an example of what we're talking about. So let's say that we have some relation. We don't know necessarily what the relation is. We know what the line of the relation looks like. We know a point on the line of the relation. And we know that this is a line with a slope of 3. How do we find the equation representation of this relation? Well, knowing it's a slope of 3 gives us some info. We know this should be y equals 3x plus b. We don't know what this b value is. That's why it's a variable right now. We don't know it. So what do? Well, we know information from one version of the relation, from this graph representation. So we can take this point right here, right? Actually, let me color it like this. We can take this point and we can substitute that into the equation. Let me show you exactly what I mean. So the y is 16. So we get 16, right? That's our y value, is equal to 3 times our x value was 4, and then it's still plus b, right? That's our x value. This is our y value. Because the equation and the graph are the same thing, we can use kind of points in between them to move back and forth. Well, this is not actually that bad anymore, right? Like, this is just a normal equation with one variable over here, this b value, right? And all we're going to do is simplify and solve. So we do 3 times 4. 3 times 4 is 12. Oh, 3 times 4 is 12. 16 equals 12 plus b. And then we can subtract 12 from both sides. And we end up getting 4 equals b. So it turns out that this b up here is actually a 4. That would be the equation for this relation. We were able to use the graph, use points, all that kind of stuff, and learn how to move back and forth. Hopefully that feels cool. Hopefully that feels good. And hopefully I'll see you soon. Bye.